Alright guys, this is part 3 of our lesson on solving and graphing quadratic inequalities. Alright, the first thing we need to do is we need to find the x-intercepts of this parabola by factoring. Okay, so we already have 0 on one side, so let's just go ahead and factor this thing down. Okay, so if I do that, x squared is x times x. 6, alright, it's probably going to be 2 times 3, but if this doesn't work out, I can use 6 times 1. Alright, inner plus outer equals middle. So inner, I have 2x, outer, I have 3x. I'm trying to get a middle of 5. And that will happen if both of these are positive, so that means both of these have to be positive. Okay, to find the x-intercepts, alright, I'm talking about where the parabola is equal to 0, so I'm going to set these equal to 0. Okay, so if I do x plus 2 equals 0 and x plus 3 equals 0, that will give me the zeros of the function. So x equals -2, that's one of my zeros, alright, and x equals -3 is another one. So let's record those zeros on the number line. Okay, I always like to include 0 on my number line no matter what, in which case in this case I'm going to put 0 over here. Okay, now we've got, because we've got -2 and -3 coming. So -2, let's say that's right about here, and -3 would be like over here somewhere. Okay, it's just a quick sketch, so it doesn't have to be perfect, but 0, -2, -3, you get it. It goes that way. Alright, so hopefully you can understand that with these x-intercepts, we have divided the number line into 3 zones. Okay, the 3 zones are, oh, actually, before we do the zones, let's plot points for the endpoints here, representing these zeros. Based on this inequality symbol, am I going to use open circles or closed circles? I'm going to use closed circles because it's or equal to. If it was just greater than, then I would use open circles. Alright, so closed circles at -3 and -2. Now your teacher probably wants you to put your closed circle right on the line like that. But if you're in Mr. Burton's class, please put your closed circle above the line. It just makes it easier for me to see what you're doing. Okay, and it doesn't affect the solution or anything. So please put your graph above the line if you're in my class. So those are the endpoints of the graph. Now focusing on those endpoints of our solutions, like I started to say before, we have divided the number line into 3 zones. There's the zone to the left of -3, okay, and we have the zone between -3 and -2, and then we have the zone that is greater than -2. Okay, we have these 3 zones. So what we need to do is we need to pick a test value from each one of these zones. Alright, I like to organize my work like this. Make a little chart out of it. Okay, so I need a test value from the yellow zone. So I need something that's less than -3. I'm just going to do -4. Alright, you could do -5 or -6 if you want. Now, this one's going to be a little tricky. We need something between -2 and -3. There are no integers between -2 and -3. They're consecutive. Alright, they're 2 numbers in a row. So I'm going to have to use a decimal, okay, or a fraction, but probably let's go with decimal. So I'm going to use negative 2.5, okay, as a test value between negative 2 and negative 3. Alright, now in the pink zone, I'm just going to use 0. I always use 0 whichever zone that's in. 0 is easy to work with. Okay, now also when I substitute these test values back into the inequality, I like to use the factored form. So I'm going to use this form right here. Okay, it just makes more sense to me. So x plus 2 times x plus 3. Okay, so here we go. So x plus 2 times x plus 3, and we're doing greater than or equal to 0. Okay, so x plus 2 times x plus 3 greater than or equal to 0. And one more time, x plus 2 times x plus 3 greater than or equal to 0. So I'm going to substitute my test values in for x. Alright, so let me set this up real quick. Alright, so we're doing negative 4, so I'm substituting in negative 4 for my x values. Okay, now negative 4 plus 2 is negative 2. Negative 4 plus 3 is negative 1. Alright, and we want to see, is this greater than or equal to 0? Well, a negative times a negative is positive, so I get positive 2. And then we ask ourselves, is 2 greater than or equal to 0? And of course, yes, it is. 2 is greater than 0. So that means that x equals negative 4 is a solution to this inequality. That means that all of the values in this zone, in the yellow zone, are also solutions to the inequality. Okay, so we will show that everything to the left of negative 3 is a solution by drawing an arrow to the left of negative 3. Okay, this arrow represents all of these solutions. Okay, let's test the blue zone. In the blue zone, we're using this negative 2.5. Okay, so negative 2.5. Okay. Yeah. So feel free, if you need to, use a calculator to add negative 2.5 plus 2. Go ahead. Okay. But most of you will be able to do this in your head and see that negative 2.5 plus 2 is going to be negative 0.5. Okay, and negative 2.5 plus 3 is going to be positive 0.5. Okay, but like I said, if you need to put this in your calculator, like negative 2.5 plus 2, do what you need to do. Do you. Okay, see, negative 2.5 plus 2, that's negative 0.5, and negative 2.5 plus 3, okay, is positive 0.5. Okay, and so now we need to do negative 0.5 times negative 0.5. Now, in my mind, I'm thinking, okay, this is negative 1/2 times positive 1/2. Okay, the most important thing is a negative times a positive is a negative. So I know this is going to be a negative something. Okay, it's going to be negative, and I could really answer the question based on that. But 1/2 times 1/2 is 1/4. So it's going to be, in my mind, I'm thinking negative 1/4. Okay, but you might put this in your calculator. Negative 0.5 times 0.5, you might have done that. Negative 0.5 times 0.5, okay, that's negative 0.25. That's the same thing. Right? Either way you look at it, the question is this a true statement? Is negative 0.25 greater than or equal to 0? And the answer, of course, is no. Negative numbers are not greater than 0 or equal to 0. So that means x equals negative 2.5 is not a solution to the inequality. That means that none of the values in this zone are going to be solutions to the inequality. So we will just leave this blank to show that there are no solutions in this area. Okay? And now let's test the pink zone. Okay? So my test value is 0. So that will just be 2 times 3. Alright, so that's 6. And we ask ourselves, is 6 greater than or equal to 0? Well, of course it is. 6 is greater than 0. That means x equals 0 is a solution to the inequality. That means all of the values in this zone are solutions to the inequality. And we will show that these are solutions. Everything to the right of negative 2 is a solution by drawing an arrow to the right of negative 2. Alright, that was a pretty bad arrow. Let me just try that one more time. Okay. Okay, so this is what happened. Alright, the big picture, and we have the graph of our solution set, but we also need to write the solution in interval notation. So we'll need an interval for each one of these branches. So this branch over here goes from negative infinity to negative 3. Alright, this time we will use a square bracket at the negative 3 to show that we're including the endpoint as part of the solution set. And once again, when we have these two separate intervals, we'll use a union symbol to join them together. Alright, we're using both sets are part of the answer, so union. And this interval goes from negative 2 to infinity. Okay, so this would be considered the solution. Okay, and of course this below is the graph of the solution. Oh yeah, I forgot to mention this on example 2, but I always like to connect this back up to what's happening graphically. Okay, so please understand that this is a parabola. You know this, man. Okay, this is a parabola, and this is a upward facing parabola because it's positive. So understand this is an upward facing parabola, and these are the x-intercepts of the parabola, okay, that we found. So if you imagine the sketch here, okay, with this upward facing parabola is doing something like this. Okay, so graphically this is what's happening. And when we ask ourselves, where is the function, alright, where is the parabola greater than or equal to 0? Now, look at the part of the parabola that is above the x-axis. Okay, the part of the parabola that's greater than or equal to 0 is this part right here, the part I'm highlighting in yellow. Okay, so for my visual students, the reason why these were the solutions, can you see that this yellow part of the graph, we have the parabola is to the right of -2 when it's above the x-axis, and then the parabola is going to the left of -3 when it's above the x-axis, when it's greater than 0. So that's why the solutions are in this area and this area. And there are no solutions down here because this part of the parabola is below the x-axis. This is where the parabola is less than 0. Okay? So visually, that's what's happening. So I just thought I'd throw that in there for my visual learners. Okay, that's it for example 3. All right, if I have time, because this is taking a long time to make these videos, so I might have to say that 3 videos are enough to show you how to do this. I may or may not get to videos 4, 5, and 6. This is taking forever. And I think I've explained the concept super thoroughly, and you should be able to do these other ones on your own. But if I have time for a video 4, that'll be another video. I hope this has been helpful, you guys. I'll see you on the next video.